Hi, Mrs. B here. Let's review for the Chapter 10 test. The test is only on sections 10.2 through 10.5, and it is a no calculator test. Please try these problems by pausing the video, trying them, and then checking your answers with mine. Okay, off we go. Okay, for number 11, since you are winning 75% of the time, that means you have 75 wins out of every 100. So let's simplify that to 3/4. That'll make our math a lot easier. So we win 3 out of every 4. So how many would that be out of 16? So that ends up, solve your proportion, and you get 12 games as your answer. For number 12, there's 20 students, and the boys are 45 out of 100. So if we're trying to find students that are not boys, that would be the girls that are 55 out of 100. So we have 55 girls out of every 100, and we're trying to see how many that is out of 20. So if we just solve the proportion, we get 11 girls. So for number 13, it's probably good to make a list of the numbers from 1 to 10 to help you. If we're choosing a number that's greater than 2, that leaves us with, we have the numbers 3 through 10. So that's 8 out of our 10 numbers. Simplify that, and your answer would be 4/5. For B, we're choosing a multiple of 2. So for this, let's identify our multiples of 2, 2, 4, 6, 8, and 10. So that's 5 out of 10. Simplify that, and you get 1/2. And for C, we're choosing a number less than 10. So the only one on our list that wouldn't be included is 10. So that leaves 9 out of 10. Okay, now we're in 10.3. We're using experimental probability. So we're using the results of an experiment to write the predicted probability. So the first one, we know that there's 6 that are bruised out of 15, and we just need to simplify it to get our answer of 2 out of 5. So the experimental probability of it not being bruised would be the remaining bananas, or the 9 out of 15, which is 3 out of 5 when we simplify it. Okay, so there's 5 students with the touch screens out of 16. We don't even need to simplify that one. That's our answer. And then we're going to use that answer to see, well, how many would that be out of 144? So let's write this proportion. I can multiply 16 by 9 to get to 144. So I'm going to multiply 5 by 9 as well. And that gives me an answer of 45 students. Okay, also in 10.3, we looked at a lot of bar graphs and the like. So the first thing you want to do is see, well, how many total is that? In this case, it's colors, and I add them up, and I have 20 total. I hope you got the same. So out of the 20 total, there's 6 that are red, so 6 out of 20. We're going to simplify that to 3 out of 10. And drawing an orange, so there's 3 out of 20, and that is all we can do there. And not drawing yellow, so since there's 2 yellow, that means there's 18 that are not yellow out of 20. So let's simplify it, and we get 9 out of 10. And drawing a color with more than 4 letters in its name, if you look at them, there's 3 out of the 6, so half of them. Not red, I'm sorry, I'm disregard that. Just red and blue are not counted. So if we add up the green and the yellow and the orange and the purple, we do get 10, so 10 out of 20, and it ends up being 1/2. Okay, and then in 10.4, we had to make tree diagrams to find our sample space. So for the ice cream problem, I'm just going to show you what I came up with here. is this tree diagram where I start with the two different types of cones. And from the cones, I break it down into the three flavors. So it looks kind of like a tree. But the whole key to this is making the sample space. So from that tree diagram now, you need to read each of the tree branches to read the sample. So for example, this one goes with this, waffle with chocolate, and so on. Go down the list and you get those 6 different combinations there. Okay, for number 5, we're going to get a big answer here because you can start. What I do is I draw my 7 slots. Those are the 7 pictures. So for the first picture on the wall, I have 7 choices. After that, I've used one there, I have 6 left. And then there's 5, and then there's 4, and then there's 3, and then there's 2, and then there's 1. So you actually have to multiply those together to get your great big answer of 5,040 different arrangements of the pictures. Okay, so for number 6, we're finding a probability of 2 events. Rolling an even number, there's half even numbers on a number cube, and tails is a half also. So multiply them together, and the probability of both events occurring is 1 out of 4, 1/4. For number 7, let's see, again, 2 events. Our first event, rolling a number less than 5, that would be 4 out of 6. I'm going to simplify that to 2/3 and multiply that by the probability of flipping tails, which is 1/2. When I simplify that, I end up with an answer of 1/3, or 1 out of every 3 times we should have that happen. Okay, and then in our last section, I just wanted to remind you that it's a good idea to keep track of your total in each problem and what you're really trying to find. So for the first one, I'm trying to find a dependent event, meaning there's going to be 1 less the second time we pick a color out of 15. So the first time we do red, we have 6 out of 15. And the second time we do red, we end up with 5 out of 14. And I'm going to do a lot of simplifying here to get to my final answer, which ends up being 1/7. So for the second problem, this is what I do is I saw there were 6 total, and now we have independent events, which means we put them back in the bag after the first time we pick. So for this one, we have 2 out of 6 the first time, and the second time we still have 6, and now it's 4 out of 6. Simplify everything, you end up with an answer of 2 out of 9. And then our last problem, we have 18 total independent events. We're picking red, and then we're picking gray. So for red, I simplified 3 out of 18 to 1 out of 6, and I multiplied that by, now I have gray, 4 out of 18, and that's 2 out of 9. Simplify everything, and you get 1 out of 27 as your answer. Okay, I hope this video helped you. And on the bottom of your test, draw a smiley face and you'll get an extra 2 points. Okay? Take care, everybody.